Building a custom exhaust system for a Bugatti Chiron per sport is not like modifying a normal sports car. Everything becomes more difficult because every component around the exhaust exists inside one of the most advanced automotive platforms ever engineered. The exhaust system does far more than create sound. It controls heat management, gas flow, pressure balance, durability, weight distribution, emissions behavior, and even influences how the engine delivers power. Inside a high-performance engine, combustion creates enormous pressure and extremely hot exhaust gases that must leave the engine efficiently. If the exhaust design restricts flow too much, performance can suffer. If flow becomes poorly controlled, engine response characteristics may change. Engineers spend thousands of development hours balancing these variables. On a Bugatti-level hypercar, that precision becomes even more critical because the engine operates at extraordinary performance limits. The Chiron platform uses a massive quad-turbocharged W16 engine capable of producing extreme thermal loads. Under heavy acceleration, temperatures moving through exhaust pathways become severe enough that ordinary materials cannot survive long-term operation. Material choice, therefore, becomes one of the biggest engineering decisions. Lower-grade steel may degrade over time under repeated heat cycles. Titanium becomes attractive because it combines strength, lower weight, corrosion resistance, and excellent temperature capability. Titanium also changes sound characteristics. Different metals resonate differently. Stainless steel often produces one style of exhaust note. Titanium can create a sharper, more exotic character with distinct high-frequency tones. For hypercar builders, sound engineering becomes almost as important as mechanical engineering. Pipe diameter decisions directly affect gas velocity. Larger tubing can reduce restriction, but may change flow behavior. Smaller tubing increases gas speed, but risks creating unwanted back pressure under high load. Engineers carefully calculate internal dimensions because airflow behavior inside an exhaust system determines much more than volume. Collector design matters. Merge angles matter. Transition points matter. Even small geometry differences influence pressure waves traveling through exhaust piping. Advanced performance exhaust systems often use flow modeling and scanning technology before fabrication begins. Digital measurement allows engineers to map mounting points, clearance requirements, thermal expansion zones, and packaging limitations. On a Bugatti platform, packaging becomes especially difficult because the rear section contains complex cooling systems, turbo hardware, aerodynamic components, structural elements, and heat-sensitive materials positioned extremely close together. Heat shielding becomes another major engineering challenge. Exhaust temperatures can impact nearby wiring, carbon fiber structures, sensors, and surrounding mechanical systems. Specialized thermal barriers and strategic placement decisions protect surrounding components from long-term exposure. Valve technology adds another layer of sophistication. Modern valved exhaust systems allow different sound profiles depending on driving conditions. Under relaxed driving situations, valves can direct gases through quieter pathways for refinement. Under aggressive acceleration, valve operation changes flow routing, creating greater sound intensity and a more emotional driving experience. Engineering those transitions smoothly requires calibration work beyond simple fabrication. Resonance tuning becomes equally important. Hypercar exhaust development is not simply about maximum noise. Uncontrolled frequencies can create unpleasant drone inside the cabin during highway driving. Engineers tune chamber sizes, pipe lengths, and flow characteristics to shape sound quality itself. The objective becomes creating an exhaust signature people instantly recognize. Deep, low-frequency energy creates presence. Higher frequency tones add excitement. Turbocharged engines introduce another challenge because turbochargers naturally reduce exhaust sound intensity compared with naturally aspirated engines. Builders often work carefully to unlock more engine character without negatively affecting turbo performance. Weight reduction also enters development discussions. Factory systems prioritize durability, regulation compliance, refinement, and production requirements. Custom fabrication sometimes creates opportunities to reduce weight through advanced materials and simplified architecture. Every kilogram removed benefits vehicle dynamics. Hypercar engineering always values efficiency alongside performance. Building an exhaust for a machine like this ultimately becomes a balance between science and emotion. Data shapes decisions. Engineering defines limitations. But sound creates feeling. When people imagine a rebuilt Bugatti firing into life through a fully custom system engineered specifically for its extreme personality, excitement grows because exhaust design transforms more than performance figures. It transforms identity. The right exhaust system changes how a machine feels, sounds, and connects emotionally with drivers and audiences. That is why this part of the rebuild carries so much importance. It is not simply metal tubing under a car. It becomes the voice of the entire project. The fabrication process behind a custom Hypercar exhaust system pushes engineering into an entirely different world from ordinary aftermarket modifications. Once scanning and measurement stages finish, engineers move into design development, where hundreds of small decisions begin shaping the final result. Computer modeling becomes extremely important because modern performance exhaust systems depend on precision. Engineers first build detailed digital representations that allow them to study routing possibilities, thermal behavior, mounting requirements, airflow efficiency, and available packaging space before physical manufacturing even begins. On a machine as advanced as a Bugatti Chiron per sport, available space becomes one of the biggest limitations. Massive cooling hardware, turbo systems, aerodynamic structures, suspension components, heat shielding, and structural elements occupy nearly every area engineers normally use. Routing exhaust pipes through that environment requires problem solving at the highest level. Pipe length becomes important because exhaust pulses behave differently depending on distance traveled. Equal flow characteristics across both sides of the engine influence sound consistency and performance balance. Even slight differences can create unexpected acoustic behavior or unwanted pressure changes during operation. Every curve receives attention. Every connection point receives analysis. Engineers often avoid sharp directional changes because smoother transitions improve gas movement characteristics. Mandrel bending technology becomes valuable because it preserves internal pipe diameter during manufacturing. Poor bending methods can create restrictions inside the system, reducing efficiency and affecting overall behavior. Welding quality becomes equally critical. Hypercar exhaust systems experience repeated thermal expansion and contraction cycles during operation. Temperatures rise rapidly under acceleration and fall again during cooling periods. Weak welds eventually fail under those stresses. Fabricators therefore prioritize consistency, penetration quality, alignment accuracy, and material integrity throughout manufacturing. Titanium fabrication introduces another layer of complexity because titanium behaves differently from ordinary steel during welding. Specialized procedures help prevent contamination that could weaken material strength. Precision becomes mandatory rather than optional. Small fabrication errors can create vibration problems, fitment issues, thermal complications, or long-term durability concerns. Sound engineering development continues alongside physical construction. Engineers often evaluate how pipe diameter transitions influence acoustic personality. Resonator placement affects frequency behavior. Chamber volume changes influence tone depth. Valve positioning impacts how sound transforms between quiet and aggressive operating modes. Modern performance exhaust development blends mechanical engineering with acoustic science. Builders often chase emotional impact alongside performance improvements. They want startup sound that feels dramatic. They want acceleration sound that creates excitement. They want downshifts that deliver character without becoming uncontrolled noise. Hypercar owners expect refinement together with intensity. Achieving both requires enormous development effort. Weight optimization continues influencing decisions throughout fabrication. Titanium remains attractive because reducing exhaust system mass improves overall vehicle efficiency. Lower weight benefits acceleration behavior, handling characteristics, braking response, and overall dynamic feel. Hypercar engineering always pursues marginal gains because small improvements accumulate into meaningful performance advantages. Mounting strategy becomes another hidden challenge. Exhaust systems move slightly during thermal expansion. Engineers design mounting points capable of managing movement without creating stress concentrations or vibration transfer problems. Flexibility matters alongside strength. Heat protection systems receive equal attention because surrounding vehicle components must survive repeated exposure to elevated operating temperatures. Thermal barriers, spacing considerations, airflow management, and shielding solutions work together, protecting nearby systems from long-term damage risk. Sensor integration introduces another challenge entirely. Modern hypercars contain sophisticated electronic management systems monitoring multiple operating parameters continuously. Exhaust modifications must coexist with complex software environments, controlling performance behavior across different driving conditions. Builders therefore balance innovation against compatibility requirements. Throughout the fabrication process, one objective remains constant: create something worthy of the machine itself. Hypercars represent extreme engineering ambition. Any custom component attached to one carries enormous responsibility. A properly developed system must feel intentional rather than experimental. It must feel like an evolution rather than simply a modification. When fabrication reaches completion and final installation begins, months of engineering decisions finally move toward their ultimate moment: the first startup, the first throttle input, the first time years of design principles, fabrication skill, acoustic tuning, and engineering discipline combine into sound. That moment transforms technical work into emotion. And for a rebuilt Bugatti project carrying global automotive attention, that sound becomes more than engine noise. It becomes proof that engineering ambition and determination can build something extraordinary. The first engine startup after installing a custom exhaust system becomes one of the most important moments in an automotive build, because that single moment reveals whether months of engineering decisions actually achieve their purpose. Before the engine even starts, technicians move through detailed inspection procedures because hypercar systems leave no room for mistakes. Mounting brackets receive final torque verification. Heat shielding positions get checked again. Clearance measurements around suspension components, cooling hardware, and structural elements receive another inspection. Exhaust valve operation gets confirmed. Sensor connections undergo verification. Engineers understand that performance vehicles operating at this level punish shortcuts quickly. A small issue ignored early can become a major problem later under extreme operating conditions. Once mechanical verification finishes, attention shifts toward calibration and system behavior. Modern hypercars rely heavily on electronics, working together continuously. Fuel delivery systems, turbo management, ignition timing, airflow calculations, thermal management systems, and exhaust monitoring technologies communicate constantly. A custom exhaust must integrate into that environment smoothly. The goal extends beyond creating dramatic sound. The system must operate correctly across idle conditions, daily driving situations, partial throttle movement, and maximum performance scenarios. Engineers often collect operating information after installation because real-world behavior reveals details digital simulations cannot always predict perfectly. Temperature patterns receive monitoring. Pressure behavior receives analysis. Exhaust valve transitions receive observation. Acoustic characteristics receive evaluation. Builders study how the engine responds across different operating ranges because performance consistency matters as much as peak excitement. Sound tuning itself becomes one of the most fascinating areas of development because exhaust tone involves much more science than most people realize. Engine firing order influences acoustic personality. Pipe length influences resonance behavior. Chamber volume shapes tonal balance. Material composition changes sound texture. Turbocharged engines create unique challenges because turbochargers naturally absorb some exhaust energy before gases reach the rear system. Engineers therefore work carefully to preserve character while maintaining efficiency. Hypercars demand emotional sound without sacrificing refinement. Low engine speed behavior matters. Mid-range acceleration matters. Full load operation matters. Aggressive downshifts matter. Startup sound matters. Builders chase a complete acoustic experience rather than focusing only on maximum volume. Drone elimination often becomes extremely important during development. Loud does not automatically mean better. Poor frequency control creates unpleasant cabin resonance during normal driving conditions. Advanced exhaust development therefore includes acoustic balancing strategies designed to maintain excitement without creating fatigue during longer drives. Valve programming adds another dimension entirely. Variable exhaust systems allow multiple personalities inside one vehicle. Comfort settings may prioritize smooth refinement. Performance settings can unlock aggressive sound character. Track focus operation often emphasizes maximum emotional impact. That flexibility creates a broader driving experience because the car adapts to different situations rather than forcing one behavior everywhere. Thermal management evaluation continues after installation as well. Exhaust systems operating near extreme temperatures affect surrounding vehicle systems continuously. Builders monitor heat exposure patterns carefully because protecting nearby components remains critical for long-term durability. Carbon fiber structures, cooling systems, electronics, wiring pathways, and surrounding hardware all depend on controlled thermal environments. Hypercar engineering constantly balances performance against reliability. Long-term durability testing ultimately determines success. Initial excitement means little if reliability suffers months later. Engineers evaluate material stability under repeated heat cycling. Weld quality faces long-term stress exposure. Mounting systems experience vibration forces repeatedly. Components expand and contract thousands of times through normal operation. Premium engineering demands performance alongside endurance. The reason enthusiasts become fascinated by projects like this extends beyond horsepower numbers or financial value. People connect emotionally with machines that demonstrate craftsmanship and ambition. Custom hypercar development combines science, engineering, creativity, persistence, and passion into something people can experience through sight, sound, and emotion. When a rebuilt Bugatti eventually rolls out with a fully developed custom exhaust system, delivering its first true performance demonstration, viewers will not simply hear mechanical noise. They will hear engineering decisions transformed into character. They will hear fabrication work transformed into identity. Most importantly, they will hear proof that determination combined with technical skill can turn an impossible project into reality. One of the biggest reasons enthusiasts become obsessed with exhaust systems is because sound changes how people experience performance. Horsepower numbers impress people on paper. Acceleration figures create headlines, but sound creates emotion. Sound stays in memory. People forget technical specifications faster than they forget the feeling created when an extraordinary machine fires to life for the first time. That emotional connection explains why companies developing performance exhaust systems invest enormous time studying acoustics, resonance behavior, gas flow dynamics, and frequency control. Hypercar owners do not simply buy transportation. They buy experience. They buy drama. They buy engineering emotion delivered through speed, design, and sound working together. For a machine as extreme as the Bugatti Chiron Sport, creating the right exhaust character becomes especially important because the car already operates at a level few vehicles in automotive history can reach. The W16 engine represents one of the most ambitious production power plants ever engineered. Massive displacement, 4 turbochargers, extraordinary cooling demands, incredible performance capability. But turbocharged engines naturally create acoustic challenges because turbochargers absorb energy moving through the exhaust stream. Naturally aspirated performance engines often produce sharp mechanical sound character more easily. Turbocharged systems require deeper acoustic engineering to unlock emotional sound without compromising efficiency. That challenge becomes even more important during custom development because builders attempt something factory engineers already spent years optimizing. Performance exhaust engineers often study sound frequencies, almost like musicians study instruments. Different frequencies create different emotional responses. Deep low frequencies create power and presence. Mid-range frequencies influence aggression and richness.